Welcome to Cloud Realities live at MWC24. We're a conversation show exploring the practical and exciting alternate realities that can be unleashed through cloud-driven transformation. I'm Dave Chapman.
I'm Sjoukje.
And I'm Rob Kernan.
And yes, we are still in Barcelona at the Mobile World Congress. And for those of you that actually don't know what the Mobile World Congress is, it is a large industry event that's organised by the GSMA, which is a trade body for tech communications and connectivity. But I think it's probably fair to say, when you're walking around it, that it's expanded beyond that original brief.
Massively. There's all sorts of vendors here that we would identify with, like the traditional tech world.
Yeah.
As I said, it's all integrating together. And it's become much more than the core that is what was...
Converging, some might say.
There's that word again, that nice word.
But it is a very interesting show to walk around because, first of all, it is massive. I think we said that on the last show. It's some 30,000 attendees more than AWS reInvent, for example, which is also a very significant conference. But it's the bewildering amount of stuff that's on display here that's really sort of taken me aback.
Well, this morning we arrived at the wrong entrance of the show, and it must have taken us 20 minutes to walk through all the halls.
Sorry, 20. We arrived. I think taxi dropped us off in a different building at Hall 8. We're in Hall 2. So yeah, exactly. It's a 20-minute walk from one building to another.
You need a Sherpa, a pack, a few meals, some medical supplies to make sure you get to the other end of the conference.
You definitely need that. We all need some assistance here, that's for sure.
Yeah, that is very true. Yes.
The other thing I thought was amazing is that I think we talked about this a little bit yesterday on the show, that the booths are absolutely massive.
Huge.
And I've heard in one... Well, there's a flying taxi on display
taxi.
somewhere.
Well, there's some booths that take up almost like a third of a hall for the real big ones like Huawei and things like this.
Right.
It's absolutely colossal.
I mean, they're sort of double-story, sort of almost buildings in their own right, really.
Yeah.
I'm going to check that out, that flying taxi.
I want to see it. I've got Blade Runner. I've got Blade Runner sort of visions in my mind.
Have you built it up in your mind?
I have built it up in my mind.
High expectation.
Wow.
Yeah.
Well, the spinner in Blade Runner and drones. I assume it's a drone-based thing, but we'll check that out and we'll talk about that in a future episode while we're here. As we said yesterday, there are 6 topic areas. There's 5G and beyond, connecting everything, humanizing IT, manufacturing DX, game changers, and our digital DNA. So on the first show from the conference, we covered connecting everything. We talked about RAN, and we talked about 5G and edge and the huge evolution that's going on in that space. Today we're going to tackle game changers. Let's give you a sense of how the conference is positioning game changers. It asks where technology is going in 2024, and looking ahead is always a tricky business. It's particularly calling out how big data is shifting to data that's enabling AI and personal experiences. It's talking about the investment in quantum. It refers to elements of sustainability. It talks about digital and physical worlds coming together in things like AR and VR, which is all over at the moment with Apple's release of a headset, for example. So in other words, that the potential of the sort of technologies that we need for the world going forward are arriving, and they are here. And that's something to explore, I think. Rob, have you seen evidence of that at the show so far, do you think?
Yeah, well, so there's a few things happening. Everything's got AI in it, as you might expect.
Yeah.
They've added it in. But there's
AI-enabled everything.
AI-enabled everything, absolutely. But I like the mix of, there's consumer electronics here, there's backbone, Qualcomm's here, chip manufacturers, all sorts.
Right.
But there's lots of exciting things going on right across the board.
Yeah, the thing that I don't know whether it's necessarily fits into game changers, but the one thing you found that looked quite good is a Minority Report style laptop.
Oh yeah, completely clear display that comes up, completely changing the user interface.
Yeah,
as a sort of thing you can see through, and it melds in. So that going back to the AR VR thing, the device we touch and see is changing. So the human interface is very much evolving here as well.
Radically changing. Anything standing out for you, Sjouk?
Yeah, a couple of great stuff. I really like the desktop lamp to improve your mood.
Oh yeah, I saw that. Yeah. Dave needs that. He does. He needs that especially today.
I definitely do today.
And the Galaxy Ring. I like that one.
What's the Galaxy Ring? I missed that.
that it has sensors to measure your heart rate and to also measure your sleep patterns, etc.
Oh, so a smart device that just is like, there you go.
Honestly, crazy, isn't it?
The future is now.
So we're lucky enough to have a number of guests talking to us about the Game Changers theme. Later on in the show, we're going to talk about non-terrestrial networks, some really fascinating stuff there, with Greg Pelton, the CTO of Iridium, and Richard Deakin, the Chief Executive of Stratospheric Platforms. But before we get to that, I am delighted to say that joining us on the show today is Paul Armstrong. He's the Global Sales Director at Digital Services at Schneider Electric. Welcome, Paul. How are you doing?
I'm very good, thank you.
How's your show so far?
The enormity of the show is just beyond belief, really. I understand there's about 90,000 plus attendees in the show. I mean, I've never seen an event
people everywhere.
like this. And it's tech everywhere, right? Yeah. So, it's an amazing show.
Bewildering, isn't it?
It is, yeah. I've never seen tech like it. Some of the discussions you were talking about there and some of the AI that's out there. It's really future.
Anything particularly resonating with you that you've seen so far?
A lot of the AI type offers on the go, so it reflects in the industry which I'm in, which is very embryonic compared to where the world is today.
Right. To be honest with you, I think actually a lot of industries typically feel like that. The sort of tech innovation that's going on around the actual implementation is always a bit of a lag, I think.
It is, yeah, absolutely. And certainly the industry I'm in and what we're going to talk about today is, as I say, it's embryonic and something that we need to work on in the future.
Well, before we dig into that, do you just want to tell everybody a little bit about what you do?
Yeah, so I work for a company called Schneider Electric. I'm the Global Sales Director for Digital Services. So I've spent, let's say 20 years in Schneider Electric, 30 years in the industry, which makes me old, by the way. So
join the club.
So my role, and its very easiest format, is to digitize the world. That's it really. So
small remit, innit? That's tired. You just digitize the world
on my own. So
it's an interesting KPI.
Yeah,
must be quite busy. What do you do on the day off that you get?
Well, I mess around on a golf course, playing very badly. But So basically, I work in many market segments. So anything from a bank to a coal mine to a hospital to, a major manufacturing facility. So quite diverse in what I work to. And really, it is all about trying to get this industry up to a level where they're using AI to change the way they run the business.
Well, let's maybe use that as a bridge into one of the things you've been working on recently, and it surrounds the world of smart buildings.
Yeah.
So let's maybe start with just a bit of definition and level setting. So in your mind, what is a smart building and where is the industry up to today?
So a smart building is a building that uses technology to become more efficient, both in its energy and in its operation. So the ultimate goal is to have a single platform that allows more visibility and allows companies to better manage their business, both, like I say, with energy and operation. So using AI and data to bring that efficiency. So a smart buildings starts off like this. Emerging trends in the business is where companies bring in, let's say, renewable energy sources and things like that, just to help them towards that sustainability and journey towards net zero. But many companies are quite far from this goal,
right?
And that's the biggest challenge, really.
I would have thought many buildings themselves haven't been retrofit with whatever you need in a building to be able to manage it on a minute detail.
Yeah, and I think the key challenge in many buildings and many companies is that people don't even know the baseline, so they don't even know what they're using today.
What it looks like.
So how do they know how to get? So a lot of companies talk about their journey for sustainability and things like that, and it's great in words, but when you have an old facility which has very old technology inside of it, you have to change, and companies don't have the skill set, they don't know how to do it, so that's where companies like ourselves come in. They don't always have the capex in place to retrofit the buildings, so that's not readily available, but the equation's quite simple, it's digital plus electric, equals decarbonisation, and that's the message which we need to take out there.
And when people are building new buildings, I'm assuming by default they're adding this stuff in. So everything new gets it, but there is obviously a huge amount of real estate that's old and the retrofit very complicated.
Yeah, there's legislation which you have to meet. There's certain standards that you have to meet when you're building new facilities. But in any given market, there's a cost to everything, and sometimes you can get contractors who design out the good things that you put in there. We know what perfect looks like, and we've got our own facilities that have that. Which
there must be a good argument though for saying making sure it's in, because there must be a sort of savings. It's saving the planet, saving your money. There's got to be a good business case behind it, I'm assuming.
Yeah, it's the return on investment, and how do you prove the return on investment? So it's I end up in a lot of discussions on ROI, that's for sure. Yeah.
Well, we talk a lot about the way in the world of cloud and online, when you compare things like FinOps, so when you're tracking your footprint on the cloud and your usage on the cloud, which you're predominantly doing for financial management, that there is actually a great deal of overlap between that and green ops, where you're actually trying to manage your kind of technology supply chains from a point of view of sustainability and minimized carbon footprint. Is it a similar kind of energy cost to consumption overlap here, or are there other dynamics going on in a smart building you need to consider?
There's lots of dynamics. It depends on the type of facility. So it's not just smart buildings, it's smart facilities, So you have to think about, the manufacturing process in let's say a food manufacturing process, or a multi-occupant tenancy, building, like office block, high-rise office block. And of course, people want more power, so they need more resilience, and they also have their own KPIs. So there's lots of different dynamics you need to take into consideration.
Right. And when you're retrofitting an old building, just give us a sense of what you're actually putting into it. So,
well, for a company to understand what they're doing, the first thing they need is some metering, some form of metering. So, you'll have old equipment. They might not have the relevant data points in for metering. So you've got to be able to measure at every level what you want to, function with your organisation. So it could be that you want to move to LED lighting in a facility. So you have to then swap out your lighting systems, and they may not be as easily compatible as they were, So there's lots of things to take into consideration, but generally it's about the age of what's there and what's new, and how easy is it to adapt.
Got it. And now, one of the things I think you've been working on recently is a thing called the Energy Command Center Initiative. You just want to tell us what that is, and what problem is it trying to solve as part of the smart building world?
Yeah, so the Energy Command Center is a plug-and-play system based on predominantly the Schneider Electric EcoStruxure platform. So that kind of sits below. It allows us to present data in a way which is understandable and actionable to many people in the organisation. So you're talking the facilities manager, or the energy manager, or the executives, or the plant manager, so it's really displaying data in a way which is meaningful. So that's one element of it. But to do that, we need to take data from multiple assets. So that could be an HVAC system in a building, it could be an electrical distribution system, could be circuit breakers, could be UPS systems for data centers, things of that nature. So taking data from intelligent assets. And then we need, and what the Energy Command Center does is it takes all that data and it sits expertise behind it.
Right.
And below that is obviously Schneider's experts, which sit below that. So we're putting expertise and artificial intelligence in place to make use of the data and guide companies on where they're going in their sustainability journeys. So the Energy Command Center achieves this objectives. It helps companies on their roadmap, as I mentioned, and they do that through the use of IoT.
Right.
Yeah.
Right.
And that plays back to the theme we had yesterday with connecting everything. Ever increasing amount of IoT connected devices, going up to 30 billion by 2030. This is one of the things where we'll see a massive increase. So every smart building will have loads of IoT. It all needs to be connected. And typically, is that wired connectivity using 5G? Is it a mix? What sort of way are you solving the...
Yeah, it can be very different. You've got various technologies. You've got wireless technologies. Everything from a wireless push button, you right the way down at this level, through, you could have 5G connectivity depending on the customer's cybersecurity challenges, or you could just go straight through their company network. The good thing about the Energy Command Center is obviously that takes the data from whichever source that we are provided it with, and it's all about interpretation of the data.
Right.
And because companies don't have the skill set necessarily, they focus on their core business activities, then that's where we step in and support.
Is it then also an automation platform?
Yeah, it's an automation platform.
Yeah. So it takes decisions based on data and acts upon it.
It takes. There's a lot of AI built in, but then there's a human behind it that interprets the AI and comes up with sensible decisions.
So tell us a little bit about the AI enablement itself. What does it do above and beyond? Above and beyond putting say all of the data into a data lake.
Yeah. So basically, we take the data, we benchmark it against how something was designed. So we know how buildings should be designed in an ideal world. We know how electrical infrastructure should be designed in an ideal world. So we take all the data points and we have AI in there that looks at a history of the last 20 years of failures of a particular component.
Right.
How did it fail in a hot country versus a cold country? How did it work in a manufacturing facility versus a commercial building? So we've got lots of different data points, lots of failure history over many years, and we use that to create the AI. Then behind that, we sit a person who looks at the AI and just determines whether that's real or not real.
Right. Okay.
So it's a bit like a human. All that knowledge combined, trained the AI, that looks at the data and then says, here's all the things you should be interested in.
Exactly.
Interesting things for you, which is quite cool because you're bringing a body of knowledge, the wealth of that to an individual use case, and then that's able to tell you what to do.
And of course, we spend all of our time continuous learning. So we take the data from a company and we continuously learn. So we find new things, we put it back into the AI, and so we're always feeding the AI.
And presumably that gives then the operators like predictive analytics, so you'll know when a certain component may well fail.
Yeah. We have various rules in there, and the rules would be, physical things, movement of plant, let's say mechanical plant. It looks at historical data and analytics, and it looks at many different failure points. So we take all of the different areas, but we also then look at things like maintenance laws and things like that. So we combine physical things, historical data and statistics, and maintenance laws, and that will allow us to determine whether we need to intervene or not intervene.
Cool. And have you got this in the wild yet? Is it installed in kind of real businesses and buildings?
Yeah, I mean, I'll just talk about we've got 750,000 critical assets connected to our systems, already. So This is not new for us. It's slow and emerging. We're just touching or scraping the surface at the moment. But if I talk about, let's say, Schneider Electric's facility in our Grenoble region of France, we've historically there we had originally 2,000 facilities. Sorry, in the year 2000 we had 27 facilities in Grenoble. We reduced that to 16, and now we're down to 4 facilities. So we've equipped that with the EcoStruxure solutions. Here, the result of this is that we are consuming 10 times less in energy than the average building across Europe.
Wow, that's quite a stat.
Yeah.
That's quite huge, and 60 times lower in carbon emissions than your average building in Europe.
Wow.
So you take a facility like this that we're in now with 8 massive halls, the potential must be absolutely huge for savings because there's lights everywhere.
Yeah.
There's lights, there's occupancy, are the lights on every day when people aren't here, all these different types of things, But our facility in Grenoble is 26,000 metres squared, of which 4,000 metres squared is photovoltaic solar panels.
Yeah.
We've got 2 vertical wind turbines, and these are producing 970 megawatt hours per year. And we've got 300 kilowatt hours of battery storage, So we're showing the way with our facilities. They've reduced in volume. So what we've done is we've brought people together into a smaller, more techie buildings, so it's quite trendy.
Optimised, trendy,
but we're bringing people together, so it's kind of your office is your home type approach, But certainly the results we demonstrate and what we do with our facilities is showing customers, the credentials of what we're trying to sell.
It's nice though, because it's an eat your own dog food situation where you've done it to yourself, proved the benefit, because you back your game, which is good.
Yeah, absolutely. And if we went out to the market talking about sustainability challenges, trying to offer new systems and technology and people, and we don't do it ourselves, it could quite easily come back to us. So, but amazing facility.
No, I mean it's getting to that point where organisations are starting to take their carbon footprints very seriously, and that's only going to get kind of more and more stringent in the years to come as more of the sort of legal considerations around it kick in, particularly in places like the EU. So, what does the future look like for you? If you cast out a couple of years from now, where do you see things like Energy Command Centre and all of the various different techniques you've been describing going?
Yeah, I think Energy Command Centre is at the start of a journey which has only just started in the industry, and I think it's only going to grow. Like I mentioned previously, people skills, businesses that don't really know where to start. They've got a tradition of 30, 40, 50 years of manufacturing or office space, so certainly the Energy Command Centre and the collection of all the data points into one single platform, sat with people behind, providing that advice, then that's an amazing solution for what's needed out there in the market. And I can only see that growing. As I say today, we're right at the start of the journey in our industry. People assume we're well advanced in it as an industry, but there's a lot of room.
Long ways to go. Well, look, Paul, thank you so much for taking some time for us today, and thank you especially for stepping in at the last minute. I know one of your colleagues couldn't make it. It's very much appreciated.
No problem. It's my pleasure.
Good to talk to you. Now, we end every episode of this podcast by asking our guests what they're excited about doing next, and given that we're at a conference in Barcelona, what are you excited about doing next at the conference?
Well, I'm going to visit some more of the tech stands. Then I might wander to the beach, and then.
That's, you see it on a map. You go, I need to go to the beach. I saw the sea from the taxi this morning. It was like
behind the docks.
Behind the docks.
It's like the hotel we're staying on is notionally right on the seafront, but actually between the hotel and the seafront is an absolutely massive dual carriageway, and
a container yard.
A number of
our producer
yards.
Strikes again.
And more like the docks, I would say.
And some quite exciting guests as well, I believe. Yeah.
yeah, exactly right. Exactly, there's a lot of fun to be had there. Right. Anyway, so thank you very much indeed, Paul. In the second half of our conversation about game changers, I'm delighted to say that we're joined by two organizations that are looking at non-terrestrial networking. So networking that's basically at the stratospheric level, and networking that's basically around satellite connectivity, all pretty critical as we evolve telecommunications platforms. So let me introduce, first of all, Greg Pelton, who's the CTO of Iridium. Greg, good to meet you.
Good to meet you. Thanks for having me.
Absolutely my pleasure. What's your experience of the conference so far?
There's so many people here and so many interesting things going on, and compared to last year, NTN is a big theme. A lot of booths are talking about it. There's a lot of solutions that are starting to come into being, so it's very interesting.
Right. Yeah. And also joining with us this afternoon is Richard Deakin, who's the Chief Exec of Stratospheric Platforms. Richard, great to meet you.
Great to be here.
And about you, have you been overwhelmed by the intersection of about almost every subject in the tech world at this conference?
Yeah, it's a vast show, but I think it underlines the need for connectivity. Everything that we see here doesn't work without connectivity. So we're really having a great time looking at some of those more difficult use cases that we can solve with non-terrestrial networks.
Right, absolutely. Well, let's maybe start with NTN and just let's get some sort of baseline definitions set. So, in your mind, particularly from the stratospheric perspective, define that for us. Like, how does it broadly function, and from a lightweight architecture perspective, what does that look like?
Sure. So essentially, the stratospheric solution you can think of as a mobile mast, but just up at 60,000 feet. So the concept's pretty much the same as a terrestrial mast. Obviously, we have a millimeter wave link up and then a frontal antenna on whatever frequency the customer wants. And our aircraft stays up for a week. It's powered by hydrogen. So the exhaust is just water vapor. So it's all very environmentally friendly, which is important. And we can connect people over 15,000 square kilometers at speeds of up to 200 megabits per second direct to handsets, which is great. So my mobile phone is my handset for our NTN solution.
Amazing. And Greg, let's go further out into space. Describe your infrastructural architecture.
Iridium is a low Earth orbit satellite constellation. We've been around for about 25 years. We launched the original one in the late 90s, and the original service was intended to be voice. Since then, we broadened out into a number of other services, messaging, data connectivity. But as a low Earth orbit satellite, you're moving with respect to the Earth at 37,000 kilometers an hour.
Right.
So being able to maintain the connectivity, a cell tower is sitting still, a satellite's moving dramatically fast. There's a lot of technical complexities of being able to maintain that connection and hand off from satellite to satellite as they pass over, every few minutes. We have a global constellation. We have service every square inch of the Earth, and about 2.3 million users on the network today.
Wow. And when you look at use cases for technologies like this, so my presumption is a little bit to your point, Richard, that the world is becoming ever more connected. Every second of the day, there's something new that requires some form of level of connection. There is also the element of places in the world that are hard to reach, whether that be having to do that from a business perspective, or whether you're doing that from a societal perspective and trying to create a connected world. What's your perspective on use cases and how you've seen them evolve over the course of the last 5 years?
Yeah, I think it's very interesting actually. When we started the journey, and we were fortunate enough to have a significant Series A round of investment from Deutsche Telekom, we were very much focused in on being essentially a network provider for telcos. But the more we've developed the system and the more people we've spoken to, the more you see the utility of providing services from HAPS.
Like direct-to-consumer services.
Yeah, direct-to-consumer, very definitely. We've got very interesting conversations going on at the moment where the antenna, for example, can transmit on Wi-Fi frequencies. So people are saying to us, hey, we don't have a telco license, but we've got a license for Wi-Fi and we'd like to light up areas with Wi-Fi, which is interesting. Another good one, cruise liners. Packed with thousands of bored people all wanting to connect. And
they've got to get their TikTok, Richard.
They have indeed, and all the kids as well on there. Yeah. So typically, most satellite systems can connect at a few hundred megabits per second. We can connect cruise liners at 4,000 megabits per second, and one HAP can connect 10 ships at that speed. So, it's a game changer from that point of view. But obviously the economics as well for telcos are very attractive at a network level.
And that's a consumer perception, isn't it? That it's just expected now, especially with the younger generations, that they can just get internet where they are at high speed without any issue. Maybe not appreciating the technical complexity of delivering that, but you are answering that use case. So
yeah, I think that's a really good point actually, and I think this is where HAPS are very complementary to satellites as well, because a lot of satellite operators are looking at sort of, multi-dimensional strategies. So GeoSats, MEO, LEO, and HAPS have definitely got a role to play there. And in fact, one of the really interesting use cases from a satellite point of view is being able to connect our HAP using lasers, free space optics, to satellite constellations. And then for a satellite operator, you're able to turn your satellite constellation into direct-to-device.
Right. Okay. So you chain the technology together, and there's a new consumer experience underneath it.
Exactly. So the backhaul goes back via satellites, but that really is a game changer.
Greg, do you have a perspective on that?
It's an interesting scenario. There's satellites, because of where they are, can connect anything below them, and so we even have some small satellites today that use us for connectivity. Airplanes, a lot of airplanes, a lot of shipping, so there's nothing today flying that really uses optical links for connectivity, and this technology is coming into being right now, and there's some experimentation. So I think if we go fast forward 7, 8, 9 years, we're going to see a lot more of these optical links, which is a tremendous amount of capacity you can run through the system once you've got that.
So multi-layer orbital devices, like all basically connecting to be able to work directly with handsets.
Exactly. And then the next piece though is you also need to connect the satellites together,
right?
Because what satellite the HAPS is connecting to could be is changing over time, and so the satellites have to be able to, once that traffic comes up, route it amongst themselves to get down to where you want it on the ground. And so it becomes a network in space essentially.
Right. And what so far from your perspective, Greg? What's the use case evolution that you're seeing beyond what we've just talked about there, which is the direct to consumer handset?
Yeah, well, we've always supported a lot of use cases. Our customers are primarily business, but we do have a fair number of consumer customers. We go to market through partners, so you don't tend to see Iridium on the device you're using,
right?
But it's the Iridium service if you're using a Garmin InReach, or if you've got a Caterpillar earth-moving machine. It's our service behind that. And there's a huge market from different kinds of businesses to utilities to governments, as I said, to consumers as well. What this sort of evolution to NTN is bringing is where these networks have been mostly proprietary in the past. Now we're seeing convergence of cellular networks and cellular technology with satellite. And that's what the NTN, non-terrestrial network, really means about how do you get the cellular technologies off the ground. Once you do that, you open up these huge ecosystems and customer bases who are consuming cellular technology today, and they become customers for satellite networks as well.
Right. And because satellite networks historically have been really about hard to reach areas and geographically complex telecoms. But I think what you're saying is that the convergence that we're seeing here is something that actually makes the satellite network not only an interesting market, but also just a much more like a much more available transport platform.
Absolutely. And there are scenarios or use cases where even if you have terrestrial coverage, satellite might make more sense.
Right.
If you're a company that has a global presence and you don't want to have business relationships with carriers in every country, being able to have a business relationship with one carrier and getting service worldwide is important. And so I think that there's a lot of opportunity to bring satellite and make it adjacent to these other networks and other businesses, and this technology convergence is really driving it.
Right. I mean, I've even got a situation where down the road in the village that I live, my friends, the fibre stops.
It's not one of those, like, you can see it from your front room.
200 yards before their house.
So have they gone for satellite internet?
The hilarious thing, this is a bit of a raffle, but the hilarious thing is
we're good at those.
They had a conversation about, like, well, how are we going to fix for this problem? And Sian, our friend, she was like, in charge of trying to resolve this problem for the household. And she went with sort of like a SIM card solution that you plug in. Doesn't work very well.
Oh, no.
So she's getting a lot of feedback on that. So it sounds like what we found here is a solution to that problem.
It definitely is a solution to that problem. Now, you still have to solve the economic problem too. I mean,
You're right.
It has to be a good business case, and if you're selling gigabits of connectivity or kilobits of connectivity, it depends. But I think that the technology is reaching the point where we can solve these problems, and it'll become cheaper and cheaper to gain that access, which will then open up to more and more customers.
And I think there's that the commercial sector getting more into space. And that it's driving a very different economic structure, isn't it? It's becoming a cheaper price point, and the whole mechanism of sticking a satellite into space is becoming more commoditized almost. I don't know if you agree, but I know it's still a very tough job. So let's not underestimate the getting something into space. But it seems to be it's more prolific. There's a lot more satellites up there. It's becoming almost standard in the way we approach it.
It is, and it's driving an innovation cycle because definitely the cost of launch is a barrier to entry. But there's also, Moore's law and technical innovation is allowing you to put more and more capabilities on orbit as well. There still are some challenges. Space is hard. There's no question about it.
Right.
And offering reliable service from space takes a lot of experience and a lot of good technology underpinning all that. Software and hardware. And there's I think we talked earlier about spectrum. What frequency you're using.
Yeah.
Few people have tried Wi-Fi. There's issues with that because, of course, there's a lot of Wi-Fi things around that cause interference. most of the radio waves, the spectrum used from satellite are regulated. And so the ITU coordinates, but every country has their own rules about who's allowed to broadcast in that spectrum. And then the bands, some of them are narrow band, some of them are broadband. So this kinds of services you can offer changes depending on what spectrum you have and who has licensed you.
Right.
We actually have the good fortune of our spectrum is licensed worldwide. So that's why we have a global network and we can provide connectivity anywhere on Earth. But many others are regional and they're only licensed in certain countries or certain geographies. And so this is a big non-technical issue that has to be solved in order to enable more connectivity.
And what's your process at the moment for getting them up there? Like how regularly are you sending up new kit? And how are you actually doing that? Are you renting space on the spacecraft or are you actually launching them yourselves?
And we have our own satellites. Yeah. In our original network,
how are you getting them up there?
By rockets.
Right.
Rockets. How much? No, Dave, but just think about rockets. What a day. What's your average day look like?
Yeah.
A rocket launch, that's going to be exciting, as an experience.
It is, but I guess there is your business plan and your networks for different satellite operators. Some have more frequent launches, some less, depending on the number of satellites and the lifespan of the satellites.
Right.
Ours are built for a long lifespan. Currently we're predicting about 17 years on this constellation, and if it might go longer than that. So we've got 66 active satellites, mesh network in space, and 14 spares. We started launch, and this is our second generation constellation. We replaced the entire first generation without interrupting any service. Most of that was done between 2017 and 2019.
That's a migration and a half, isn't it?
It is incredible.
That is a migration.
Imagine digging up a cell tower and continuing service.
All right.
But the last thing I would say is we did launch our final 5 spares last May.
Right.
So we still had one more launch, so it was exciting to see that.
Were you there when it? That's what we said.
Yep. And we launched primarily on SpaceX. They've done a great job for us.
Right.
And so everything's up there. Everything's performing properly, and it's going to be a while before we have to launch anymore.
Because you always hear the stories about space where something goes up, and inevitably you're going to have some technical issues at some point because these are incredibly complicated devices, and you just think that's a difficult fix.
Yeah.
Yeah.
Have you watched For All Mankind?
Yes.
The TV show.
Yeah.
At the end of season 2, where Gordo and Trace have to fix the moon base, I think that's a pretty clear articulation of how difficult it is to work in space, isn't it?
It is. One of the sort of insights that I think is critical to our network that we're being at from the start was our satellites are software defined. So we update the software regularly and put new capabilities in there. A lot of satellites previously were just hardware systems. You had a little bit of software for command and control, but the basic function was all hardware. And so we can change the behavior if we need to.
Right.
If we find new use cases or problems they want to solve, and that's a key part of our business.
Fascinating stuff. Richard, coming back to you, and actually the same set of questions really, which is like, just give us an insight into your management of the stratospheric platform and how you're, getting them up there, keeping them up there, subsequently migrating.
Yeah, sure. Obviously, how we deploy them depends on the use cases that we're looking at. But if I look at the UK as a good example, so the modelling that we've been doing for the UK, you'd need just 24 high-altitude platforms. Each platform effectively has 450 individually steerable beams, so that's a bit like turning up with 450 cell towers. Essentially. So coming back to your point of sort of fibre running out and everything, one of the advantages of this, of course, is you don't have to go through all that planning permission process.
Right.
Worrying about digging trenches and the cost of all of that. So it's a very cost-effective solution. Again, just sticking with the UK as an example, we're looking at having the fleet of aircraft based in Glasgow. They would take off, fly around in the stratosphere for a week. We've been working very closely with NATS, National Air Traffic Services, on how we deploy that. At the end of the week, another one goes up. They do a hot swap.
Have you been up in one?
Well, they'll be unmanned, so I haven't volunteered.
Okay, I would imagine there's a good view.
I would imagine, but hopefully through a camera.
Might be a bit chilly though.
Yeah.
Sorry, I didn't mean to.
No problem. And then they come back down and so you go on. But it's a very cost-effective way of doing it, as you might imagine from a CapEx point of view.
Sure.
When you're comparing one aircraft with 450 masts, not to mention the OpEx of running the masts as well. Hydrogen, I think has turned out to be a really good choice. When we started, hydrogen was quite exotic.
Right, yeah.
Of course, everyone's piling in now.
Yeah, everyone's on the trend.
You know, we did our initial business case modelling, because as you say, it's about the economics as well, not just about the technology. When we started, hydrogen was going to be around $6 a kilo. Now we're looking at a price more around $2.50 a kilo.
Wow.
So, you know, all the economics, I think, have really helped us from that point of view. And unlike rockets, we've designed our mission to be really boring. You know, basically this thing takes off, goes up, flies
Take all
around.
the risk out of it.
Exactly. Flies around in circles for a week and comes back down.
Well, phenomenal. I mean, just to bring our conversation today to a bit of a close, I'm just interested in where you think we might be in the next 5 or 10 years. The level of innovation here is obviously extremely high, and the possibility in terms of direct-to-consumer and solving for some of the sort of world's connectivity problems seems to be we're not only in reach of that, but there with it, right? So what does the next 10 years look like for you?
Well, I think we're there conceptually today, and there's a lot of experiments and tests that are looking positive.
Right.
And so think back to, you know, in 1990 and what cellular networks look like. We're kind of there. We have the technology. Do we have global coverage and interoperability and all the services people want? And can you watch Netflix? No. You know, so that will happen. I'd say over the next 10 years, that's going to mature in stages, and you'll see more and more constellations of satellites launched that will have these kinds of capabilities and more interoperability between the terrestrial network and the satellite network.
And do you see us within that time, if you've got like, I don't know, let's say 10 to 20 years on the life of each satellite, how do you see us managing the proliferation of stuff in orbit? Do you see services where we're actually taking that stuff back down again?
There's a lot of investment in that area, and you know, historically there's been no real obligation for operators to think about sustainability. We for instance design our satellites. We navigate them. There's fuel in them. We can move them in space and to avoid junk, or when they reach the end of their useful life, to bring them back down.
Right.
And then we're seeing the start of regulation that's going to require satellite operators to have that plan to deorbit their satellites. But there's still a lot of junk up there that has to be dealt with. There's some companies being funded today. They're looking at removing the junk, but there's no business model for that. Like there's no one willing to pay for that.
No.
It's international space.
These like, hey, let's all be sustainable is easy when you don't have to pay for it, doesn't it?
Exactly. Yeah. So, you know, we may see in the future more of an insurance model, you know, where you pay an insurance fee when you launch a satellite or launch a rocket that then goes to a cleanup fund that brings things down. I think that's the only way to make it practical, worldwide.
That's fantastic. I think it's really very important. Or we'll end up in the Futurama state where rockets have to burst through, kind of huge swathes of a junkyard up there.
Yeah, well, the junk wins in that case.
Yeah, exactly. And Richard, what do you see the next 10 years evolving like?
Yeah, well, I think the arrival of non-terrestrial network technologies is really going to accelerate access to connectivity globally. I mean, at the moment, there are around 4 billion people who incredibly are still not connected to the internet. And, people are then deprived of, telemedicine, education, schooling, all those sort of really important things. So I think there's a lot of benefits there that are going to drive some really interesting business cases. These sort of technologies, I think, shift telecoms onto a different cost base altogether.
Right.
Just one of our high-altitude platforms can connect 500,000 people on WhatsApp doing video calls at any one time.
Wow.
So, huge capabilities.
Right.
I think one of the other things as well is that if I look at some of the technologies coming down the tracks, you're talking about sort of 5 years plus. 6G is now, being spoken about. I know many people would be quite happy to have 5G.
Workable 5G.
Yeah, indeed, or even
you just
4.
have one that works.
Even 4G. Exactly. But non-terrestrial networks, I think, have got a really interesting role to play there. I mean, we've been doing a lot of work naturally with Deutsche Telekom, who are of the view that they're not going to be able to roll out 6G without HAPS being part of the mix.
Right.
Which, from our point of view, I think is great. But now there is a solution there that's really going to accelerate some of those very high data rate technologies.
Well, if I could just build on that.
Of course.
So, we have an initiative. One of the things I'm excited about, we announced an initiative just last month at CES, where we're going to support standards-based 5G protocols on our satellites.
Right.
Historically, we've been proprietary because there was no 5G, 25 years ago. But we see the opportunity to expand the market and provide that kind of connectivity for users by supporting these standards. And so and because we have software-defined satellites, we can implement new protocols on them. So this is a big initiative. It's going to take a little while to get implemented, but I think we're trying to lead this convergence effort right now, and help achieve that vision.
Fantastic. Well, look, guys, thank you so much for spending some time with us today, and what I'm sure is an absolutely packed conference schedule.
It's also the most exciting part. The space bit is the bit that's exciting.
I was literally just about to say,
did I steal your thunder?
Who doesn't want? Who
doesn't want to talk about space? It's cool.
It is like you paint such a fascinating mental image and picture, and really exciting things to come. So thank you very much indeed for that. Now, we end every episode of this podcast by asking our guests what they're excited about doing next. And since we're in Barcelona and we're at the MWC, I would say, what are you excited about doing next in Barcelona? Richard?
We've still got quite a few more meetings. We've got a really good panel tomorrow on HAPS technology.
Cool.
So for the audience, they'd be very welcome to attend or sort of tune in. But I think I'm just enjoying the momentum here of, as we were saying earlier, HAPS and non-terrestrial networks and satellites very much being sort of flavour of this year's show.
Greg, what are you excited about doing next?
To be honest, I'm excited about going home.
Yes.
For a couple of reasons. One, this is exhausting. There's just so much going on. It's so exciting and so many people to talk to, but also just the relationships we've been building, the things we've learned, being able to incorporate that. We have a program we're running right now that there's a bunch of partners we've been talking to, and now I see the next few steps along the path too. So I'm excited about getting back to work, rolling up the sleeves.
Great. Well, guys, enjoy the rest of your conference.
Thank you very much.
So a huge thanks to our guests, Greg and Richard. Thank you so much for being on the show. Thanks also to our sound and editing wizards, Ben and Louis, our producer Marcel, and of course to all of our listeners. We're on LinkedIn and X, Dave Chapman, Rob Kernahan and Sjoukje. Feel free to follow or connect with us, and please get in touch if you have any comments or ideas for the show. And of course, if you haven't already done that, rate and subscribe to our podcast. See you back in the MWC reality soon.